Good morning. Today we are doing our last CO75. Today we are looking at comparing theoretical probability and experimental probability. So it's still those probabilities that we've been working on this unit. So we're going to look at what theoretical and experimental actually mean. So for theoretical probability, it's what should happen. And you'll notice I put should in a quotation mark. Should happen. So if we say we flip a coin, you get a 50-50 chance if it's going to be heads or it's going to be tails. So you flip it one time, you get heads. The next time you flip it, you should get tails, right? Should be even numbers on heads or tails. That's not what always happens. It's what theoretically should happen. If we went by the numbers, that's what would happen. But experimental probability is what actually happens. So when we are actually experimenting, doing our events, it is what actually happens. So theoretically, I'd flip a heads, then I'd flip a tails. But in reality, I could flip a heads, tails. And Julian could flip a heads, then a tails, heads. So we could flip differing amounts because when you're actually doing something, we don't know exactly what's going to happen until you actually perform it, right? Until you actually do the event. So we're going to be looking at, please stop. We're going to be looking at what the theoretical probability should be. Let's take our feet off the device, move the device out from under the table, and let's put our attention up front. Thank you. We're going to look at what the theoretical probability is, what we think will happen, what should happen if we're going by the numbers. Then we're going to look at the experimental probability and see what actually does happen. How close are we to that theoretical probability? Okay, because experimental probability could be way off or it could be really close. It could be right on. There's a wide range that we could get, and we're going to do some activities to actually see this in action. So our first experiment that we are doing is we are going to be flipping a coin. So I actually have pennies I'm going to quickly and quietly pass out to everybody. I need to get these pennies back from you when we are done with this objective because we will use it again for my next year's class. So everybody gets one. Please do not do anything with it. Keep it quiet until I tell you it's time to do something. Okay, so I don't want to hear any coins being flipped. Just put it on your binder and keep it still and quiet. Thank you to those of us being quiet with the pennies. That's not a penny, that's a dime. So I want us to use pennies because you might get a different result using a dime. Please put it away. Thank you. Okay, so first we're going to fill in some numbers. So theoretically, if we flip this coin, so we're not doing it, theoretically it's just numbers. If we flip this coin 10 times, how many times should we get heads? 5. Why 5?
Because it's a 50% chance.
Because it's 50% chance, half of it. So if we flip it 10 times, half of those times should be heads. So theoretically, we should get a heads 5 times. How many students are in our math class?
21.
There are 21 altogether. We have one person absent, so I'm going to be that one person.
I thought we had 22.
No, 21. 21.
When Mallory left.
Yeah.
When Mallory.
So 4, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20, or one absent would be 21. I will be number 21. Okay? So there are 21 of us that are going to be doing this activity. So if each of us flips a coin 10 times, how many total flips would that be? How did you get 210 so fast? What did you have to do? We multiply 21 times 10. And when you multiply anything times 10, you just have to put that 0 on the end. So if there's 21 of us, and we each flip 10 times, 21 times 10 is 210. So if we multiply by 100, we'd put 2 zeros on. So theoretically, how many times should a heads be flipped if we have 210 flips? James? 105 times. So half. Half should be heads, half should be tails. So this is where our fun part comes in. Listen first. We are going to flip our coin 10 times and keep tallies of your results in our boxes. So if you are listening at home, you can flip your own coin to follow along with us, but we're going to use the results that we are getting in person, live in class. So I'm going to flip my coin 10 times. I'm going to put tally marks for my heads or tails in the box. You're going to flip your coin 10 times, and you're going to tally up your heads or tails. So I'm going to erase this to scroll up. You can go ahead and get started.
Professional way is heads. So far I've got heads, tails, heads, heads, heads. Oh, I got 6 more. That's pretty cool. What is it land on? How does it wait, heads. How much? Who's it? I got 5 and 6. I got 6 and 4. What did you get?
When you are done flipping your coins, and count up your tally marks. How many heads did you flip? How many tails did you flip? You're going to put your numbers in. Then you're going to answer your question. Does the experimental probability of you flipping a coin 10 times match that theoretical probability of getting 5 heads? My answer was no. I flipped 4 heads and 6 tails. Is there anybody who got a yes? There are a few of us, there are 5 of us who actually got 5 heads and 5 tails. Aiden, did you have 5 heads and 5 tails?
Oh, no.
If you did not have 5 heads and 5 tails, you did not make the theoretical probability. Does that mean that you're wrong? No, because theoretical probability and experimental probability are different. So I'm going to come around now and I'm going to collect our pennies. So we should all be done by now. I can't do anything about it right now. I'm going to grab I'm not sure why I'm hearing whistling. That's never something we do, especially while I'm recording. Thank you. Azalma, thank you. Okay, so now we're gonna tally up our class results. So, I'm gonna put mine in first, and we're gonna go all the way up to 21 of us. So I got 4 heads, 6 tails. When I call your name, you're just gonna tell me heads first, then tails, A and B. JT,
4 heads, 6 tails.
Riziki,
6 heads, 4 tails.
Amelia,
6 heads, 4 tails.
Matthew,
5 and 5.
Aiden H,
9 and 5.
Nora, Melina,
6 and 4.
Enzo.
6 and 8.
Well, we only were supposed to flip it 10 times. So we're gonna put 6 and 4, because you told me your heads first. Gigi,
5 and 5.
Taya,
7 and 3.
Isabel,
7 and 3.
James Z,
7 and 5.
Nolan,
5 and 5.
Logan,
4 and 6.
Bennett,
6 and 4.
Jillian,
9 and 1.
Olivia,
2 and 8. 5 and 5.
and Lincoln.
3 and 7.
Did I get everybody?
No, 3 and 1.
So, here's what we're going to do. We have to count up. How many heads did the class flip? So we're going to use our calculators and make sure we're all getting the same number.
96.
If I can find my calculator. Okay. So, 4, and you should have these numbers filled in on your chart. So we've got 4 plus 6 plus 4 plus 6 plus 6 plus 5 plus 5 plus 4 plus 6 plus 6 plus 5 plus 7 plus 7 plus 5 plus 5 plus 4 plus 6 plus 9 plus 2 plus 5 plus 3. So I got 110. Is that what you guys got?
Yeah.
Might have missed one. Somebody else got 110? Other people got 110? Or did I go wrong? Did somebody else get 110? Okay, so we're going to go with the 110. Now we need to count how many tails the class flipped. So we have 6 plus 4 plus 6 plus 4 plus 4 plus 5 plus 5 plus 6 plus 4 plus 4 plus 5 plus 3 plus 3 plus 5 plus 5 plus 6 plus 4 plus 1 plus 8 plus 5 plus 7. And I got 100.
I would say.
What? This is an 8. James, did you get 100?
Well, because got 110 on the first one, there's 210 clips, and automatically because yeah, that's what I did.
Well, I was just double checking our math.
Yeah.
Okay, so yes, 100 plus 110 gives us our 210 flips. So we were looking for 105. So does the experimental probability of the class flipping a coin 10 times match the theoretical probability? No. It doesn't, because we didn't get 105, but we're getting closer. Some of us, look at that, some of us had 9 and 1. But when we add it to our class, we're getting closer and closer. 9 and 1 is very different than 110 and 100. When we do the whole class, when we did 210 flips, we got closer. Everybody got closer to that theoretical probability. Some of us lucked out and got 5 and 5 right away, but the majority of us did not. So we're getting closer. So if we looked at, I had 4 and 6. So let's say if I'm looking at my heads, I had 4 divided by 10. I had a 40%. But now if we look at 110 divided by our 210, that's a 52%. 52% is much closer than that 40%, right? It's only 2% off of the 50 versus 10% off of the 50. So by doing it as a whole class, we got closer to that 50%. So now let's look at our next page, and we're going to do another experimental probability. But first we have to do the theoretical. So now our experiment number 2, we are rolling a dice. Theoretically, if you roll a dice 120 times, it's a regular dice that has 6 sides. How many times should each number be rolled? What do you think, Aiden H? How did you get 60?
Oh my God, that's 6. I thought it was
JT?
20.
How did you get 20?
Because it's 6, like 20 times 5 is 100. So just add
So if I do 120 times and I divide it by my 6, I get my 20. So each number is going to be rolled 20 times, theoretically, right? That's the mathy number part. We have 21 students in our class. If each of you rolls a die 120 times, how many rolls would that be?
2,520.
We multiply those together and we get 2,520. Theoretically, about how many times should each number be rolled? If we're rolling 2,520 times, thank you, Aiden, for raising your hand. What did you get?
1,200.
So there are 6 numbers on a dice. What math did we do to get the 20? We divided 120 by 6. So now we're rolling 2,520 divided by 6. What'd you get, JT? 4,200. 420. Use that extra 0 on there. So each number should be rolled 420 times. So fill in that top part, and then we're getting a dice. And you need to count 120 rolls. You actually have to roll it 120 times. Quietly, get started as soon as you get your dice. If they all have 6 numbers, please give one to Enzo. 120 times.
I'm making my college.
When you finish, you count up how many of each number to fill in right underneath your table.
What comes after 94?
I need you to finish up your rolling of the dice in the next couple of minutes. We will finish discussing this tomorrow. So for my friends at home, we hope you are well. We hope to see you soon. We will finish this tomorrow.